Welcome to The Explainer. Today, we're tackling a really fascinating mystery. Why does artificial intelligence struggle so profoundly to create any kind of deep, lasting narrative impact? We're diving into some groundbreaking research from the Bulut doctrine to uncover why this isn't just some quirky limitation of AI, it's actually a systemic threat to the future of literature itself. I mean, it's a question you've probably asked yourself if you've ever prompted a large language model to write a story. Why do AI narratives feel so incredibly flat and lifeless? Well, to figure this out, we actually have to completely shift our perspective. We have to stop viewing literature as this mystical, subjective art form built on vague feelings and start looking at it as a strict, physics-based system. We have to look directly at the mechanics of human attention and biology. And that brings us to a concept called narrative engineering. This is a discipline within the Bulut doctrine that completely redefines how we evaluate text. Basically, we strip away all that cultural noise and build what researcher Levent calls a biological operating system for reading. The goal here isn't just to convey a nice message, it's to generate an objective, measurable biological response in your autonomic nervous system.
Section 1. The Engineering of Narrative and Objective Projection.
Let's look at how human emotion actually functions as a physical signature in text, using a methodology called objective projection. So, in traditional writing, we usually rely on abstract labels, right? We just declare someone is sad or angry. But objective projection replaces those abstract labels with measurable physical parameters, things like luminous decay, thermal gradients, or acoustic impedance. The writer doesn't just hand you the emotion, they hand you the physical evidence, like the temperature of a room or the specific sound of a door clicking shut, and force your brain to actively reconstruct the emotion from those physical cues. To really see this in action, let's contrast the told mode with the shown mode. Take the told mode, which is just a surface declaration. Fatma was full of deep longing. Her heart ached and her hands shook. It's totally passive. You read it, and honestly, you instantly forget it. Now compare that to the shown mode, which uses objective projection. 3:40 a.m., tea untouched, edge cooling, phone placed screen up in the center of the table. Notice how there isn't a single emotional label there? The abstract word longing is completely suppressed. Instead, you get raw physical data. Your brain has to look at that cooling tea and the screen up phone and actually build the feeling of desperate anticipation itself. Now, part of why that shown mode example is so incredibly effective is because of something called the vacuum variable. This is the narrative power of structural absence. It's when an object, a sound, or a movement that logically should be present is intentionally left out, like that untouched cup of tea or an unanswered phone. This structural absence triggers our brain's completion drive. We are forced to actively fill that gap, and that process locks the scene deep into our working memory. Section 2. Information friction and entropy. So why does this act of reconstruction hook us so powerfully? Well, it comes down to narrative entropy. Represented by this formula, narrative entropy basically measures the structural complexity and the cognitive load that a narrative system demands from its reader. It calculates how information friction multiplies with causal branching, which is essentially the number of possible futures a scene opens up over the time frame of the story. If this entropy is too low, the story is completely predictable and boring. If it's too high, it's just meaningless noise. Objective projection is designed to hold us right in that perfect optimal zone. And a huge part of generating that optimal entropy is information friction. Think of this as the measurable cognitive resistance you encounter when decoding narrative data that's been deliberately obstructed or suppressed at the surface level. It's kind of like how a tire needs physical friction to actually grip the road. A story needs information friction to grip your attention. Without it, your brain stays totally passive and the scene vanishes without a trace. The mental reconstruction required by objective projection is exactly what provides this necessary friction. Section 3. The machine's failure. Enter summarization bias. Okay, so what exactly happens when artificial intelligence tries to process this beautiful, friction-heavy inferential structure? Well, researchers ran a detector pilot to find out. Now, for public accessibility, this pilot was framed around the old concept of show, don't tell. But make no mistake, its true operational target was rigorously testing for objective projection. They had human raters and LLMs look at the exact same scenes. And the results? The machines easily picked up on superficial surface-level features, but they completely failed at the semantic inferences required by objective projection. They were literally blind to the underlying physical structures that demand active narrative inference. And here's the thing, this failure wasn't just random, it was highly directional. The research identifies this specific failure as summarization bias. This is the systematic tendency of large language models to take the rich, physical parameters of objective projection and collapse them into flat told-mode labels. The AI looks at a complex inferential structure, like the cooling tea and the phone on the table, and just swaps it out for an abstract summary label, like, "She felt longing." It entirely destroys the information friction. Section 4. The evaluative threat. Now, this bias is definitely annoying if you're just using an AI to generate a draft. But it becomes a massive systemic threat when the AI starts acting as a judge. You see, summarization bias operates under two distinct regimes. The generative regime is what we just covered. The AI defaults to declaring emotions instead of rendering them, which puts a hard ceiling on quality. But the evaluative regime, the LLM-as-Judge scenario, is far more dangerous. In this regime, the AI actually rewards told-mode explicitness and penalizes shown-mode suppression. Because it can't process the inferential structure, it just assumes the text lacks emotion, giving it a lower score than a text that flatly declares, "She was incredibly sad." This is an absolutely crucial problem. As large language models are increasingly used as automated editors, literary feedback tools, and reward models, they're creating a really dangerous selection pressure across the entire industry. If these systems consistently reward told-mode explicitness, they're going to systematically downgrade the exact cognitive friction that makes human literature memorable in the first place. We're looking at a directional degradation toward flat declaration, literally stripping the biological impact right out of our narratives. Section 5. Testing the machine. So how do we empirically prove this is a systemic failure of narrative entropy and not just, an AI preferring shorter sentences? The Bulut doctrine uses a very rigorous three-step testing protocol. Step 1 is matched stimulus construction. Researchers create scene pairs, one told and one shown using objective projection, that are perfectly matched for word count and reading level. Step 2 is the generative test, prompting the AI to see if it can actually render the shown mode without defaulting to abstract labels. And step 3 is the evaluative test, having the AI judge those scene pairs against a human baseline. By controlling for length, this protocol proves conclusively that summarization bias is a fundamental inability of the machine to parse the structural absence and cognitive load that defines high-level human literature. As we wrap up this explainer, I want you to think about the books on your shelf. Think about the AI systems that will increasingly act as gatekeepers for the stories of tomorrow. If this LLM-as-Judge regime continues to expand, will our future narratives be allowed to retain their friction-heavy human complexity? Or will they be systematically flattened by the machine into abstract, forgettable labels? Ultimately, what we choose to value is still up to us.